Let me ask you something strange. If I told you that in 1999 a group of physicists ran an experiment and the results looked like the future was reaching back and changing the past, would you believe me? No time machine, no science fiction, a real experiment in a real lab, published in a real physics journal. And here's the part that keeps people up at night. The experiment worked. The data was real. Physicists checked it again and again. It wasn't a mistake. But what it means, that's where this story gets weird. Stay with me, because by the end of this video, I'm going to tell you what was actually going on in that lab. And I promise you, the truth is stranger than the myth. But it's strange in a way almost nobody on the internet gets right. This story starts like all good physics stories, with a man staring at the universe and asking a question that sounds completely insane. His name was John Wheeler. Now, Wheeler wasn't some random guy. This is the physicist who worked with Einstein, the man who coined the term black hole. When Wheeler asked a question, the entire physics world stopped and listened, and in 1978, Wheeler asked this: what if a decision I make today could determine something that happened billions of years ago? Here's his thought experiment. Somewhere out there, billions of light years away, there's a quasar, an ancient, blindingly bright object. Its light left home before the Earth even existed. On its way to us, that light passes a massive galaxy, and the galaxy's gravity bends the light around itself. Some light goes left around the galaxy, some goes right. Gravity acting like a giant lens. So a single photon, one particle of light, arrives at your telescope tonight, and it had two possible roads to get here, the left road or the right road. Now here's Wheeler's insane question: which road did it take? You'd think, obviously, it took one or the other. Billions of years ago, that's history, that's done, carved in stone. But quantum mechanics says not so fast. Wheeler realized that depending on how you choose to measure the photon tonight, with this device or that device, you get two different answers. Measure one way, and the photon behaves like it took one specific road. Measure the other way, and it behaves like it took both roads at once, like a wave interfering with itself. And you make that choice tonight, billions of years after the journey supposedly happened. So, did your choice tonight decide what the photon did before the dinosaurs? Wheeler called it the delayed choice experiment. For years, it was just a thought experiment, a ghost story physicists told each other, until someone decided to actually do it. Okay, before I tell you about the 1999 experiment, you need to understand the single weirdest fact in all of science. Don't worry, this takes 2 minutes, and it's the key to everything. It's called the double-slit experiment. Imagine a wall with two narrow openings, two slits. You fire tiny particles at the wall, one at a time. Behind the wall is a screen that records where each particle lands. Common sense says each particle goes through the left slit or the right slit, and you get two piles behind the wall. Simple. But that's not what happens. What actually appears on the screen is a pattern of stripes, many stripes, bright, dark, bright, dark. This is called an interference pattern, and it's the signature of a wave. It's what you get when something goes through both slits at the same time and overlaps with itself like ripples on a pond. One particle, both doors, at once. I know how that sounds, but wait, because it gets worse. Physicists said, fine, let's cheat. Let's put a tiny detector next to the slits so we can see which slit each particle actually goes through. Catch it in the act. They turned on the detector and the stripes vanished. The moment you watch which door the particle uses, it stops acting like a wave and acts like an ordinary particle. Two boring piles. Turn the detector off, the stripes come back. It's as if the particle knows when it's being watched. Now, hold that thought. It knows when it's being watched. Remember that sentence, because at the end of this video, I'm going to come back and tell you what that really means. And it's probably not what you think. But first, 1999, the experiment that made everything explode. A team of physicists, Yoon-ho Kim and his colleagues, built a machine designed to trap the universe in a contradiction. Here's the setup. Simplified. They fire a photon at the two slits. Right behind the slits, there's a special crystal that does something almost magical. It takes that one photon and splits it into two twin photons. Entangled twins, meaning whatever we learn about one instantly tells us something about the other. Twin number one, call it the signal photon, flies straight ahead to a detector and gets recorded. Click, done. Its position is written down. That's history now. Twin number two, the idler photon, is sent on a longer journey. Mirrors, beam splitters, a maze of optics. It arrives at its own detectors later, after its twin has already been recorded. And here's the diabolical part. The maze is built so that when twin number two finally lands, one of two things happens, essentially at random. Path A. The maze preserves the information about which slit the original photon went through. Path B. The maze scrambles that information forever. Erases it. This is why it's called the quantum eraser. So now think about what this means. The first twin has already been detected. Its fate is sealed, recorded in the past. Then, afterwards, the universe decides whether the which path information gets kept or erased, and when the researchers looked at the data. Whenever the information was erased, the first twin's data showed interference stripes, wave behavior, both slits. Whenever the information was kept, no stripes, particle behavior, one slit. But the first twin was recorded before any of this was decided, so the internet drew the obvious conclusion, and you've probably seen the videos. The future changed the past. The later measurement reached back in time and rewrote what the first photon had already done. Some videos go further. The universe is a simulation. It only renders reality when observed. Consciousness creates the world. Millions of views, genuinely spine-chilling and genuinely wrong. Now here comes the part of this story that almost nobody tells you. And honestly, I think the truth is even more unsettling. Here's the question every viral video conveniently skips. If you look at the first twin's data by itself, just that detector, just those clicks, before knowing anything about the second twin, what do you see? Stripes? No stripes? The answer, neither. You see a smeared, formless blob, fog, no pattern at all, and that blob never changes. Not before the second measurement, not after. Not one data point ever moves. So where did the famous stripes come from? They came from sorting. After both experiments are done, the researchers take the second twin's results and use them like a filter, like sorting a deck of cards by suit. Show me only the first twin detections whose partner ended up at eraser detector number 1. Pull out that subset, and inside that subset, hidden in the fog, there's a stripe pattern. Pull out the subset for detector number 2. Stripes again, but shifted, offset. And here's the beautiful part. Add the subsets back together, and the stripes cancel each other out perfectly. You get the blob again. The stripes were always buried in the fog, all of them, overlapping, hiding each other. Nothing traveled back in time. Nothing rewrote the past. The past sat there, completely unchanged the entire time. What changed was the question. The second measurement didn't alter the old data. It gave you a new way to sort the old data, a key to a pattern that was invisible without it. No signal to the past, no message from the future. This is the mainstream physics consensus. The experiment obeys ordinary quantum mechanics from start to finish, and you cannot use it to send information backwards in time, not even one bit. And Wheeler's photon from the quasar? Same resolution. Your choice tonight doesn't reach back billions of years. It determines what kind of question you're asking. And the universe answers the question you actually ask, not the one you imagine you asked. Now, Remember that sentence from earlier. The particle knows when it's being watched. Time to fix that sentence. Here's the biggest misunderstanding in all of popular quantum mechanics, the one that launched 1,000 mystical YouTube videos. The word observer. When physicists say observation, they do not mean a human. They don't mean eyes. They don't mean consciousness or thoughts or intention. An observation in quantum mechanics is any physical interaction that leaves a trace, a detector firing, a single air molecule bouncing off the particle, a stray photon. A grain of dust can be an observer. The particle doesn't know you're watching. The particle is disturbed by being touched, and any interaction that extracts witch path information is a touch. That's it. That's the whole magic trick. So, no, I have to be honest with you here. Quantum mechanics does not say your thoughts create reality. It doesn't say wishing rearranges atoms. The idea that consciousness collapses the quantum wave was an early speculation, and it faded because no experiment has ever supported it. If someone sells you quantum manifestation, they're selling you a word, not physics. But don't leave yet, because what quantum mechanics actually says is, I think, more profound than the myth. It says this: before an interaction, before a measurement, a quantum system genuinely does not have a definite answer. Not we don't know the answer. The answer does not exist yet. Reality, at its foundation, isn't a finished painting waiting to be looked at. It's more like unresolved potential, and the kind of measurement you set up determines which kind of answer can exist at all. Ask a wave question, reality answers with a wave. Ask a particle question, reality answers with a particle. The universe doesn't hand you the truth. It hands you the answer to the question you built your apparatus to ask. And here, carefully, honestly, as an analogy, not as physics, is the thing I actually want you to take home. That 1999 data never changed. The blob was always a blob. But hidden inside it were patterns that only appeared when someone sorted it with the right key. The stripes were always there, invisible, until the right question was asked. Your life generates a blob of data every single day. Events, conversations, setbacks, coincidences. And like that detector, the raw record is just fog. What turns fog into pattern is the filter you sort it with. Sort your days by evidence that things go wrong for me, and you will find a crisp, convincing pattern. The data supports it. Sort the same days by moments that opened a door, and a completely different pattern emerges, and the data supports that too. Both patterns were always in the fog. Neither is fake. The measurement you choose decides which one becomes visible, and which one you end up living inside. That's not mysticism, that's not the secret, nothing rewrites your past. But the meaning of your past, that's a sorting problem, and you're holding the filter. Did the future change the past in that laboratory in 1999? No, the past never moved. But something in that lab is still true, and still strange. The world at its smallest scale refuses to have properties until it's asked about them. Reality is, in a very literal sense, an ongoing conversation, and the questions are half of it. Wheeler, the old man who started this whole story, had a phrase for it. He said, "We live not in a universe that sits there finished, but in a participatory universe." He didn't mean magic. He meant something quieter and maybe bigger. That asking is not passive, measuring is not passive, attention is not passive. So here's my question for you, and I mean it as a real question, not a slogan. What are you measuring? If this video made your brain itch in a good way, subscribe. Next time, I want to tell you about the experiment where two particles seem to talk to each other across any distance, instantly, and why Einstein called it spooky. That story has an even better twist. See you in the next one.